Hello everyone, hope you guys are doing well. This video is prepared for you for your final exam fall 2023. So the first question comes up about the redox reaction. The simplest way for this is to look at each reactant and product to see where the simple substance went into and made a compound. Because we know that simple substance, such as just the element by itself, in here we have calcium, it has a zero charge, and when it gives a compound, it needs to have a certain charge, right? So right away from here, I can see that this is plus 2 and this is 0, and then from here, hydrogen went made a simple substance from actual compound. So that shows you that there was a redox reaction happened where calcium got oxidized and hydrogen got reduced. Everyone else in here, they just like did a double replacement reaction and nothing really changed in terms of the oxidation number. Now we're looking at the second question in here. First of all, we're looking at the overall and we want to put the charges. So sodium is 0 and chlorine is 0, sodium is +1, chlorine is -1. So we know that the oxidation gotta go from sodium 0 to +1 if they are asking for the oxidation. Now I'm gonna ignore the chlorine ones and I'm gonna look at the sodium where it goes from 0 to +1, and there you go. And this one is actually reaction, but this is written for reduction. It's not an oxidation, so that's why this cancels out as well. Now we're going to go to the third question. In the third question we have dichromate ion, sulfur dioxide, sulfate ions. Some of you asked regarding the polyatomic ion names, such as do we need to memorize dichromate ions? For this exam you won't be needing it because we will provide you with whatever necessary name and the polyatomic ion itself. So what we want you to is focus on just the balancing. Now we got chrome 207, so we got chrome 207 -2 going and reacting with SO2 making chrome +3 and then making SO4 -2. Now in here we need to first of all find what is the charge of each component here. I know that oxygen is -2 to sulfur is +4 in here, and inside this is a polyatomic ion, right? So oxygen is -2, so this would be +6, because 2 times 6 minus 7 times -2 gives you -2, meaning 12 minus 14 gives you -2. That's how we got this -2 in here. And then from here we know that oxygen is -2 again, and this is the polyatomic ion. And if you do the calculation, you would find that this is a +6, meaning 6 plus 4 times -2 gives you -2, which is 6 minus 8, it is -2. Now we found all of the components and the chrome is given to us. Now what they are asking in the bottom, determine and justify what is oxidized and what is reduced. Now I know that chrome went from +6 to and then chrome 3. So first of all we balance this like this, the chromes first, and then we do the charge balance. This is +12 on the left side and this is +6 on the right side. So I need to add 6 electrons in here. So we know that adding electrons, accepting electrons is reduction. So chrome, we need to look at the reaction. Where did we get the chrome +6? From chrome 207 -2. So dichromate ion in here, because it is reduced, it is an oxidizing oxidizing agent. Now, when we look at the sulfur, and we are gonna we're gonna balance the charge again. So we need to add 2 electrons in here to balance this, and this is gonna be oxidation because it lost the electrons. So when the oxidation happens, now we have reducing agent. So our reactant that has sulfur in +4 is SO2. So we write SO2 is reducing agent. Now, you can see on your question, it might ask to justify your answer. So this is your half portion where you write the answers, and justification you need to write in terms of half reaction, which are these ones in here. So if you don't write your justification, you'll lose your half a point. Now, once you have that, what we need to do is to identify and write the complete balanced reaction. So we have done this many times, but this again a review. So we can see that all we need to do with the sulfur, we need to multiply this side by 3 to make them equal in terms of electrons. So now we're gonna go back to our equation where chrome 2O7 -2 plus 3SO2 gives us 2 chrome plus 3 and 3SO4 -2. Now we need to do overall charge balance. In this case, we are gonna look at the left side. So we got the overall thing equaling to -2 because this whole thing is a -2, and this one is a compound which it has a 0 charge. And in here we got +6 and then plus -6 because 3 times -2 is -6. So we have here 0. So in order to make them equal, we need to add 2 hydrogen pluses in here, which means just adding 1 water into here. Now, everything needs to balance. We will check for the hydrogens. So hydrogens are good, and we'll check for oxygens as well. Now, if you check the left side, you have 7 plus 6 oxygens. And so since we checked the hydrogens and the oxygens on the right side, it is 13, and the left side is 13. So everything is balanced. Now your overall reaction is this. Now, since we're done with that, again, 2 more questions about redox. Now in here, in a polyatomic ion, the sum of oxidation numbers of all atoms is 0. That's true or not true? Polyatomic ion, the sum is not going to be is not going to be 0. It's got to equal to the charge of the ion. Like in here we have -2, so it needs to equal to -2. So this is incorrect. The oxidation state of oxygen in here is +1. This is not correct. This is hydrogen peroxide. In this case, this is one of the exceptional cases where oxygen is -1. So this is incorrect as well. The oxidation state of hydrogen in sodium hydride is -1. And we know that this is an exceptional situation again. So metals are always positive. Now in this case, in order to balance this out, hydrogen is -1. This is also an exceptional case, which is true. Aluminium, which is a smaller member of group 3, have an oxidation state of +3. So in this case, a member of group 3 and having +3, this is correct as well. So we got 2 options which are correct. Now, a voltaic cell, also known as galvanic cell, is an electrochemical cell that uses spontaneous reaction to generate electricity, blah, blah, blah. These are all the information you know. Draw a label diagram of voltaic cell you could make using iron metal and copper metal. Now, we have done the actual experiment in the lab. So for iron and copper, we know that iron is a stronger reducing agent then copper, so iron will be an anode, and where copper will be on the cathode. Now you need to know this stuff in order to be able to construct the diagram. So if I will quickly show, so we got in here iron, and then we're gonna have a copper in here. So I will connect them through the voltmeter, and I need to put here solutions. I need to put here salt bridge, and then I need to indicate the cations and ion flow, and I need to also show electron flow. Now electron, we know that iron oxidizes, so iron goes into the solution by oxidizing, and electrons are going up. We know the reaction, so it gives us like this, right, in cathode. And reduction happens, iron is in the anode, oxidation happens, and copper is in cathode, so copper plus 2 absorbs 2 electrons, gives us the copper metal. So that's why it gets kind of thicker in here. So the copper ions inside the solution, they are going and sticking on the copper. So this is the ion flow, and we know that, so let me draw the copper in different place too. So I'll draw the copper plus 2 ion here, going and sitting on the surface of the electrode. Now we know that this side becomes partially positive, this side becomes negative, so we need to balance it with salt bridge. So for salt bridge, I'm going to use sodium nitrate as we did in the lab. So in order to counterbalance this, the nitrate ions are going to fly through here, and then sodium ions are going to fly to here. And that's how we balance it, and everything works just like is needed. So electron is flowing from there to there. Okay, and we know that the copper plus 2 ions absorbs the electrons that are incoming into the solution, and that's what happens. Now question 6. We have 0.822 mole of SO3 placed in a 1 liter container at 600 Kelvin, and 36.7% of SO3 are decomposed when equilibrium is established. Now the reaction is in here in the bottom. We know that for a start, if we do the reaction in here, the ice chart, so I draw it for you. Now I have started with 0.822 moles or molar, because the liter is 1 in here, the concentration doesn't really get affected, the number itself. So we know that they are telling that 36.7%, meaning 2/3 of SO3 decomposes, and the 1/3 still is in the solution. So approximately. So let me calculate the percentages. I'll be right back. Okay, so 0.367 multiplied by 0.822 gives you 0.301. So we can just say it's 0.3. So that percent of SO3 is decomposed, meaning that this is gone while the rest is left here. But you need to consider the fact that we have a coefficient of 2 in here, right? So meaning that our x is 0.15, because we have 2x in here. Now this is 2x and x on this side, so we need to make again 0.3 here, and then 0.15 on this side, and that's what we have for the equilibrium concentration. Now it says calculate the change concentration of each compound. We did, so the change is this part, and calculate the value of equilibrium constant. So we need to just find the value of Kc all you need to do is Kc would be, so the product side SO2 square O2 divided by SO3 concentration square, which is 0.3 square times 0.15 divided by 0.822. Now you need to plug it into your calculator and find that concentration. Identify how the equilibrium will be shifted if the concentration of O2 will be increased. So that means that if I will add more O2 to the system, so O2 to the system, as you see, I will have more products, right? Which is disturbing my system. So my system will want to go back and decrease the O2, get it to the normal condition, which means that equilibrium needs to shift towards the left in order to use the oxygen, right? If we go from right to left, we're going to use the oxygen and make more of the SO3, right? So that's why whenever you increase the concentration of something, your system will want to decrease the concentration. So whichever side will use that up is going to be that side you choose. For example, if I had told you that if I increase the SO3, how the system will react. So our system will want to decrease the SO3, meaning that the equilibrium will shift towards the right side in order to decrease the SO3, because that's how we're going to use the SO3, right? Okay, so now we're going to organic chemistry. In here it's asking choose the type of alcohol. Now first of all, guys, you need to really do well on the line diagrams, because in this exam you will be asked lots of questions about line diagrams. If you're not comfortable with it, just you have to get it. So practice it before the exam so you get it. In here, just quickly to show you, this is CH3, CH2, this is CH, and then I have here CH3, CH2 I mean, and then another CH2, and then we got CH3, and then so this side is done, and then I have here CH2, CH2, and OH. Right away from here I can say that this is a primary alcohol. I don't need to see it, but just for your sake I wanted to show. So this carbon is by itself, so we got 2 hydrogens on it, and we told you that if we had 2 or 3 hydrogens on the carbon which is adjacent to the OH, that is a primary. If we have 1 hydrogen, it is secondary. 1 hydrogen is secondary, and if it has no hydrogens or 0 hydrogens, it is tertiary. Now this is like super simple question, you won't be asked this kind of stuff. Now, what's the degree of polymerization for vinyl chloride? So vinyl chloride, you guys need to know the names of the some of the polymers. We have practiced them. You have it in your worksheets. The one that you saw in the worksheets, you're responsible for those. So vinyl chloride is made from chloroethene. So the structure looks like this. So double bond. On instead of ethene, it's just chloroethene. The other name of it, chloroethene. Now, when you make the polymer of it, it looks like this. So CH2, CH, chlor, and then here goes like this, and you have the polymer. In here, I just tuck in this hydrogens into here for this structure, and that's how it looks like. Now you need to find the molar mass of this. So in here we got 2 carbons, C2, H3, and chloride. So carbon is 24, each carbon is 12. So hydrogen is 3 times 1, so it is 3, and the chlorine, it is 35.5. So if you sum it up, 27, and then you sum it up, 62.5, that's going to be the molar mass of C2H3 chlor, which is 62.5 gram per mole. Now, we've been told that the polymer mass is 375 1000. It's not given the units in the exam you will be given, so the unit you have here, so you need to divide the polymer mass 375,000 by 62.5, so the grams and gram per mole. So you need to find that what is the degree of polymerization, which is, well, right here, degree of polymerization with the D. And here you do the multiplication and you get the answer, which gives you 6,000. And the answer is right here. Okay, now it's asking complete the reaction and rename the reactants and products according to IUPAC rule. As you see, it is above 140 degrees Celsius, so that this means it is a dehydration reaction. Dehydration reaction in here, we know that this carbon in here, and there is one more carbon on this side, right? So we know that alpha carbon is this, and this is a beta carbon. So alpha carbon loses the OH, and beta carbon loses the H, and we make a double bond right here, right? So if we draw the product, it will be looking like this. And if you name it, we know that the longest chain needs to be picked for the name. So I can see that this is 1, 2, 3, 4, 5, 6 is the longest chain of the carbons. It has a beginning and end. We'll always prioritize alkene. We want to give it the smallest name, so it ends with hex 1 in. And over here, as you see, I have a branch. So this has 1, 2 carbons. So I know that it is ethyl. So it will, because it's located on a third carbon, it would be 3 ethyl hex 1 in. Now that's, and the name of a reactant, it just in this case, acidic environment is the name of the reactant. And name of organic product, we did it, it goes here. Now, answer the following questions concerning the given reaction. Balance the combustion reaction. Like this is something super easy. You guys have done it many times. So you put 4 and then you have 10 hydrogens on the left. So you put 5 in here and then you check for oxygen. So you got 4 oxygen, 4 times 2, which is 8. And then 5 in here, so 13. And then here, in order to get to 13, you put 6 in here and you put 1 and everything is handled. Suggest all possible products if an incomplete combustion of butanol occur. So incomplete is either soot or just CO and water. We all know it. Calculate the mass of released CO2 if the 37 grams of butanol combusted. So butanol, you need to find the mass. So we got here C4, meaning 4 times 12 plus. We got here 10 hydrogens and then 1 oxygen. So this is 48, this is 26, and this is 74 gram per mole for butanol. So molar mass of is 74 gram per mole. Now if you do the calculation, we know that the mole number is mass divided by molar mass, 37 gram divided by 74 gram per mole. This gives you 0.5 mole. Now that's the reason we balanced it, in order to find the mole ratio between them. Now it's asking for the mass of CO2, right? Now in here I have 1 mole given 4 moles of CO2. I've got 0.5 mole, and if you do the ratio, you will get 2 moles in here. If you do like that, so 2 mole of SO2, you know the molar mass of CO2 is going to be 44 gram per mole. You need to be able to find it, and the mass would be mole number multiplied by molar mass, which is 0.2 no, 2 mole multiplied by 44 gram per mole, and this would give you, mole and mole cancels, 88 grams of CO2. Now we move on to the next exercise in here. So I'm not going to do all of the steps in here, but I will explain you 4 of them, and then you can deal with the other ones. So ethane initiation and propagation steps are as follows. So this is basically ethane C2H6. Because it's an alkane, it will go through radical substitution, and you put here UV light, and then they made C2chlor 6 hexachloroethane plus 6 hydrochloric acid. Now this is the question, and now it's asking for the propagation steps, right? So this is the initiation, this is initiation, this is propagation 1. So look at here, C2H6 reacts with chlorine. Now propagation is always compound reacting with radical, given out compound, and radical again, okay? So we have here the compound is ethane, and radical comes and takes something from the compound, and right now we see that chlorine radical took the hydrogen from ethane. So now you have a radical and hydrochloric acid. Now when you go to the second step, P2, we got that radical from top. You see this guy by itself coming in here, again radical reacting with compound. In here compound is chlor 2. Now radical takes the chlorine from the compound. Now you have the structure, and then you've got chlorine radical left again. Okay, now you're curious about the P3, so P3 goes like this. In the P3 we take both of them and literally write it back in here again. So compound with a radical reacts in here. So this chlorine radicals takes the hydrogen again, so C2H4 chlor radical, and you made hydrochloric acid again. Now P4, look at the P4 in here. In this case we're not taking the both, we're just taking the radical. So C2H4 chlor reacting again with the compound chlor 2. So now this radical in here, it takes the chlorine, so C2H4 chlor 2, and again we have a radical left, as you see here. So this game continues on and on. Now in here, as you see, I only substituted 1 chlorine, right? So 2 propagation steps required for 1 chlorine substitution. And again in here I substituted 1 more, so 2 steps for 1 chlorine. So if I wanted to do 6 chlorines as I did in here, so meaning that 6 times 2, it has to have 12 propagation steps. Now just for your sake, I'll do a P5 again. So P5, look at the P5. I'm going from P4. I literally always take the even steps. Do you see the even steps? On even steps, sorry, look at the odd steps. Odd steps, I only take the radical and I plug it into the next propagation step. But for even steps, I take both of the products and I plug it in here. And then I take both of the products in the even step and I will write it in the next step. So which will be C2H4 chlor 2, and again plus radical. This radical takes the hydrogen C2H3 chlor 2 radical, and then in here I have hydrochloric acid. Now in this case I'm just going to take one of the products for the even step. So C2H3 chlor 2 reacts with normal compound, radical with the compound, and I made C2H3 chlor 3, and I made a chlorine radical, because radical always takes something. Okay, so you continue on and on. I have written 6 steps, you write 6 more steps, and you got the answer. Now, question 12. Identify state of matter for the given organic compound, match the options. So we know that the gas states are starting from, so we know that for alkanes, as we increase the number of carbons along the homolog series from C1 to C4, it stays as a gas state, but from C5 to all the way to C17, it is gonna stay liquid. And then from C18 to above, it will be solid. As you see in here, we know that the gas flow easily, so mean that gas would be less viscous, while liquid is more viscous and solid is even more viscous when you compare. So meaning that as we increase the carbon amount, viscosity, increasing carbon, viscosity increases as well. So we have here this one as a gas and this one a gas, and then we got C7 is a liquid and this one is solid. Students in the lab working with methanol and propanoic acid, write down the full reaction of this process. So this is easy. Propanoic acid meaning, so I'm going to write everything in line diagram. So propanoic means I have 3 carbons, and the last carbon gotta be COOH. This is my propanoic acid. And then I have methanol. So methanol is written like this. And then I'm gonna, because we know that methanol is here like that, right? So single line and attached to OH. And then you create acidic environment, H2SO4, and they combine. And we know that we're gonna take OH from here and H from here. To be honest, you can take from either way. It's theoretical knowledge anyways. And then you have just the structure itself. And then you have this product. And the name of the product, as you see, the main chain is the coming from acidic carboxylic acid. So, and this part is coming from alcohol. So it would be methyl, because we have CH3 in here, methyl propanoate, because this side came from propanoic acid and this side came from methanol. So it is methyl propanoate. Now, question 14, it says, which of the following given compounds are isomers of heptane? So first of all, heptane, we know that it is C7H16. So for heptane to be C7H16, you just need to have 7 carbons, right? And there should not be any degree of unsaturation, because alkanes are full. Unsaturation. Okay, so we can see that this is heptane itself, and this 2-methylhexane is the isomer. It's just structural isomer of it. And then we have 3-methylhexane. It's also the isomer because we have the same number of carbons, 1, 2, 3, 4, 5, 6 on the main chain and just 1 on the branch. Again, in here you've got 6 on the main chain and 1 on a branch, altogether adding up to 7 carbons. Now 2-methylhex3-in. Now in this case, as you see, we have a double bond unsaturation, so there is no way it can be isomer of heptane, because If you have hexane, meaning that it is C6 plus we have another methyl, so C7, and if you have one double bond, your unsaturation made it C7H14, not C7H16. Okay, so in here now we have 2243 methyl pentane. Now main chain has 5 carbons and 3 on the branches. Altogether, as you see, we got 8 carbons, C8, and because it's alkane, it is C8H18, which is not the isomer. So this is not the isomer, this is not the isomer. And if you have 2,2-dimethylbutane, we know that we can see that there are 6 carbons. So not the isomer, even though it's an alkane. And then pentane, again, 5 carbons and 1 carbon on a chain, 6 carbons, so again not an isomer. So only the top 3 in here are the isomers of each other. Now below given 2 compounds, for each of them identify the features of the structure. Is it saturated, unsaturated? Now because alkane we have a double bond, we lost hydrogen, so this is making it unsaturated. So we know that this is unsaturated. Well, this one is cycloalkane. I know that it has less 2 hydrogens compared to alkanes because the formula is CnH2n, alkane, cycloalkanes, and alkenes have the same mechanical formula, CnH2n, but that the alkenes are getting it because of the double bond, while cycloalkane is because of the structure, but they are saturated because they don't have any double bonds. So double bonds is the main criteria for unsaturatedness. Open or closed chain structure. So this one is open, as you see. This one is closed. Straight or branched. So in here, as you see, I can see the branch in here for this one. The main chain is this. So the methyl in here is the branch. Well, in here we can see that this is closed chain, which is the main chain, while this methyls in here, they are the branch. So they are both branched. Now, question 16, complete the chemical reaction and name the product. So we have to add hydrochloric acid, right? We need to go according to Markovnikov rule. Markovnikov rule meaning that rich gets richer. In here, if you check, you have 2 hydrogens in here and just 1 hydrogen in here. So I know that rich gets richer, so I need to add the hydrogen in here and add the chlorine into this side. So this will make it just like this. And the name of this, it would be 2-chloropentane. Now, question 17, above 140 degrees Celsius, again, dehydration. So alpha carbon in here and beta carbon in here. So I need to lose OH from alpha and H from beta, meaning that the structure will be looking like this. Okay, and the name of it would be just propene or prop1N, because propene doesn't have prop2 in, so normally people just write it as propene. Now on this one, this is not a line structure, but I'll still do it. So again, this is the alpha carbon, and I have 2 choices in here. I have alpha, and for 1 carbon I have 2 beta choices, either here or here. So I'm gonna follow again Markovnikov rule, but you can write either of the product. Let's go with this beta. In this case, I'm gonna make the product. I'm gonna write everything in a line diagram. So this one we had, and the double bond falls into here. And the other beta choice was this one. So this is beta 1, this is beta 2, so 1. And then for 2, we need to lose the hydrogen from here, right? So the way it looks, it will be like this. So we haven't really discussed which one is going to be the main product, so either one of them gets a full point. But we're not going to test you on this on the final exam anyways. Now you have in here below 140 degrees Celsius, meaning that we're going to make ether in here. Now I'm just going to draw the line diagram of it so you guys can see. All I need to do is to combine them. So I need to have 2 of them, right? So I take OH from 1 and H from 1 to lose the water. So water is the product. Water is the product, and then I can make it like that. And then, so this is the ether we had. This portion is coming from one of them, while this portion is coming from the other. That's how you make the ether. Now, explain the trend in boiling point according to given graph. Justify your answer referring to IMF. Now, as you see in here, boiling point is increasing. Now, on the 4th carbon, we already discussed that they are becoming liquid, the hydrocarbons. That means, as you see, the boiling point right away went to touch the 0, and as you increase the number of carbons, it's increasing, which explains because of we had the forces such as London dispersion, which is the weakest, London dispersion, and dipole, but altogether they are called just van der Waals forces. Now, due to van der Waals forces, these molecules are getting packed and they're increasing the boiling point, making it harder to separate between them. Now, compare the viscosity of alkanes with different number of carbons. We already discussed this above in the question. As you increase the number of carbons, the viscosity going up again because they flow less easily. Gas flows super easily compared to liquid. Now, question 19. Complete the reactions by drawing the line diagram of products. Now, this is just the first oxidation, right? I know that it's a primary alcohol. So in here, I need to just make aldehyde. Also, don't forget about the physical properties of aldehydes, guys. This is important. Not just alcohols, also aldehydes. Review that. And then in here, I got again a primary alcohol. I need to make an aldehyde again. And from aldehyde, I will be making one more oxidation, which is where I'll be making carboxylic acid. Now, there you go, you have the carboxylic acid. So this is the product, and then whatever the product's in here is that. And again, we have here primary alcohol. So primary alcohol, I'm just going to draw it underneath. So I will, in the oxidation, we already told you about this, that this is alpha carbon, and alpha carbon loses 1 hydrogen, and oxygen loses 1 hydrogen in the oxidation. So 2 hydrogens are lost. So you made in here, sorry, so let's make it with red. There you go. And the side product for oxidation, you have H2O. This H2 is coming from these 2 hydrogens I talked to you about, and this oxygen combines and they make a water. Now, we have another one of this in here, so we need to oxidize it. We can see that it is a secondary alcohol, so we will make a ketone out of it. Now, the ketone, I'm just going to draw the line diagram of it. There you go. We lost 2 hydrogens. One is from alpha hydrocarbon and one from oxygen. And again, you see this is a secondary alcohol, so I'll draw the line diagram. So I lost this hydrogen and this hydrogen, this is alpha, and then there you go. So water is a product, water is a product in all of them. Don't forget about that. So H2O in here, H2O in here, H2O in here as a side product too. Before I forget, I think I forgot to write, yeah, no, everything is good. Now, about the polymers, we have discussed some of them. I'm not asking you to memorize, but you need to be able to recognize certain polymers. Now, backlights you can recognize from the name. I'm not going to ask you the structure; it's kind of complicated. But we have covered the polyvinyl chloride, polyethylene, and polystyrene. If you check out our worksheets, you can see those. Sorry, you can see this one's there. So polyethylene. So in here we have polyethylene looks like this. So CH2, CH2. Sorry. This is the polyethylene, and it's made from ethylene. And then we have PVC, which is polyvinyl chloride. I already did the exercise about this. So this is the one we had. And it's made from CH2, CH chloroethene. And then polystyrene. Now polystyrene is the one looks like this. So the structure, you can sometimes people write it like this, but this is not a line diagram. So this is another way. We know that when you polymerize it, the way it looks like this. So only the double bond in here breaks down. So it will be like CH2, CH, and you need to be able to find the molecular masses of all of them. So for this one, you can see carbon, hydrogen, chlorine. This one is carbon and hydrogens. And in here, you need to be able to find this one too. So you can see that we have here 1, 2, 3, 4, 5, 6 carbons, and each one of them has one hydrogen. And then over here, like this 6 carbon doesn't have any hydrogen. And then you have another 2 carbons with 1 and 2 hydrogens. So overall you have C8. Hydrogens would be 5 plus 3, which is 8. And that's it for the overall structure, which is 96 plus 8, which makes it 104 gram per mole. And that's your molecular mass for that. For vinyl chloride, it is 62.5 gram per mole. And for ethene, you have C2H4, which is 28 gram per mole. Okay, so 28 for chloroethene, polyvinyl chloride 62.5, and polystyrene is 104. Now, complete the following task for the compound below. Before I go into this, I forgot. So you guys grab that whatever is monomers, right? So these are our monomers. Monomer. And this is the monomer. Or this one in here. They are the same thing. Okay. So question 21. It says complete the following task for the compound below. Name the compound above. It's super easy. If we need to find the longest chain, which is 6 carbons, so it would be 3 3 dimethyl hex 1 in. Draw the line diagram of Bayer test. So for Bayer test, we need to just KMNO4 if we're not asked for the whole reaction. The way it will look like this. So we break the double bond, we put one OH here and one OH here, and there you go. Write the full hydration reaction. So hydration reaction meaning that H2O and acidic environment is added to it. So we add according to Markovnikov rule. We know that this side is rich with hydrogens. So the way the product is gonna look like. So we got this. We add the H into the very left and OH in here. That's the hydration product according to Markovnikov's rule. And write down, draw the polymerization product. So polymerization product basically means that you polymerize it by breaking the double bond. So I will write the structure in here, CH2CH, like this. Okay, let me try to draw the structure in here. So we got, from here, we got 1, 2, 3, 4. So okay, so this is okay. So I'm gonna draw it in another way for you to be able to visualize. So I will literally draw the structure in here. I'm gonna just flip it. So I'll make the double bond in here. It's the same thing. I just flipped it. 6 carbons. You put your branches and the bond, and that's how it looks like. And then we need to break this double bond, right? We know that this double bond is going to be taken from here for the polymerization. And then from here, there is a polymerization starting. This is how it looks like, right? But we need to fit everything into the bracket. So in order for us to write it, I'm going to write this is CH2 and this is CH, right? So CH2, I'll make it CH, and then underneath I have so this is how it looks like, and then I will make a polymerization. There you go. This is the polymerization product. That's how it looks like. Now in here in the bottom it's asking name the ethers below. Now this is not something we fully covered, but I just wanted you to pay attention. Where did we get them from? Like you can see that this is coming from one alcohol, while this one is coming from another alcohol, right? Ether is just coming from alcohols. We practice with you just one alcohol, and we would just grab the same alcohol and we attach them to each other. This is the one we practice. I'm here trying to you refer to for the naming. Don't worry about, we're not going to give you different alcohols, but think of the naming about it. So this alcohol which made the left, so this portion, it looked like this. Do we agree? And the alcohol which made this portion just look like that. Now let's pay attention and try to name these alcohols. Now for this one, normally we say 1, 2, 3, so it would be 2-methyl, 2-methyl, propan, propanol. Well, this one we say just propanol, right? But the thing is, because this one has 4 carbons. We also call this isobutyl isobutanol. For example, in here I have what, 3 carbons, so alcohol I made it from is OH, right? Normally we call it propan 2-ol, right? But the name of this is isopropanol. It's like a second name given by scientists to them, like iso, because it's not connected on the end, but connected from the middle. They call it isopropanol. Okay? And then when you look at here again, so look at here. Normally we call this, for example, this one with 4 carbons, we call it butanol, right? Butanol. Again, in here you see that 1, 2, 3 carbons in here and 1 on the branch. This is called isobutanol, the alcohol which is coming from. Okay, now I'm gonna write you the names of the ethers. For this one is gonna be isobutyl, isopropyl, ether. While this one is isobutyl, propyl, ether. Okay, just recognize iso alcohols. Okay, this is the main point you draw out of it. Don't be like, okay, we haven't stuff, we don't have this. This is just a recognition of alcohols. If you want, I can list them in here. So propanol is this, right? Propanol. Isopropanol is this. Okay, and if it becomes a branch of something, we write it as isopropyl, and this is just a propyl. For example, we had this one, ethane, right? Ethanol, sorry. And if it becomes a branch of ester, we call it what? Ethyl, right? You need to be able to recognize. And then we have in here, so this is isobutanol. And if it becomes a part of ester, do you remember alcohol? It also has the S. In ester, we have the part that is coming from alcohol. This is going to be called isobutyl. Just like this part is going to be called isopropyl. Okay, now you have pentanoic acid. Now in here we have pentanoic acid and we have another alcohol. So pentanoic acid looks like this. So pentane and then OH in here. And we have this alcohol in here. So let's see if we got 1, 2, 3, 4, 5 on the main chain. And then we have on the third one we have OH. And then in here I have methyl. So we need to do a combination reaction, H2SO4, right? So let's see what the product we get. I need to lose OH from here and H from there. I'm just gonna literally write it as it is. And the other product is gonna be looking like I have a bend, and then I have this one and this one and this one. There you go, and we have the final product. Okay, so overall I have 1, 2, 3, 4, 5, and then I have 1, 2, 3, 4, 5 carbons, 6 carbons. make sure you write your structure properly. It shows that you bent the structure, right? Otherwise, you will lose lots of points and your structure won't be accepted. This is again a carbon. Now, question 24, it is about alcohols. We have done this in the classroom. There are two questions. It says primary alcohol with 2 carbons, right? So oxidation is added. Now you can have here, this is a combustion reaction. Primary alcohol with 2 carbons is just the ethanol, CH3, CH2OH. There's no other choice, so it would be either CH2O, COH2O, or CO2 and H2O. Now, secondary alcohol with 3 carbons. So we have to, for 3 carbons, we're talking about propanol. But it's a secondary, so this is isopropanol. Okay, it's not attached on the end, but it's attached in the middle. So when you oxidize it, you get ketone. Now, tertiary alcohol with 4 carbons. Tertiary means that this carbon which is attached to OH needs to be surrounded by 4 carbons. Now, this is the one we have, and then we have 4 carbons, right? 1, 2, 3, 4, and all together. Oxidation, there's no reaction. And the name of this is gonna be just 2-methyl propan 2O. Name the secondary and tertiary alcohols. I already did that. This is propan 2O. Write the complete chemical equation for the formation of product A and C. Name the products. So this is just propan 2-on. Everything else is named. How does the structure of alcohol affect its reactivity during oxidation? Now you need to explain that. So primary gives you aldehyde. Secondary gives you ketone. And tertiary gives you nothing. So in the last question, you can read this for yourself. Pause the video and read it. But overall, we can see that X has a general formula like that, and Y has a formula like that, meaning X is alkene and Y is alcohol, which is also why compound Y has higher boiling point than X. And bromine is used as a chemical test to identify the X, which happens with alkenes. Also, compound X reacts with water, producing tertiary alcohol. Now, this one is very important information. Now, fourth member of organic family of alkene. We know that there is no methane. So the first member is C2H4, and then C3H6, and then C4H8, and C5H10. So first, second, third, and fourth member is that. Now fourth member of its organic family. Now this is C5H10 we're talking about. And then underneath it tells you that X reacts with water producing tertiary alcohol. Meaning that if I'll add this, I will make C5H11OH, which is a tertiary alcohol. Now, I want you to get your attention to here because we know that tertiary alcohols need to have carbon attached to OH that is surrounded by carbons. There is no hydrogens. In this case, we have 4 carbons, right? But I just need to add 1 more carbon, so I can add it to either side. It won't be any different. So if I'll add it in here, right away, we got this alcohol. Okay, now let's fill it with hydrogen, CH3, CH2, and CH3. And now we want to go backwards to find the alkene that gave us this alcohol after hydration. Now there are 2 possibilities. According to Markovnikov's rules, we add OH to the carbon that has less hydrogen and H to carbon that has more hydrogen, right? So if you will go backwards and remove this OH, and you will remove hydrogen from which carbons? We got two options, either this or that, right? Because two methyls, they are the same. So we have two options for carbons. Now, if I will draw it, it's gonna look like CH3, C, CH, and CH3. It will be looking like this, right? Because this carbon is rich with hydrogens, right? While this one is poor. So when you add the water, H comes here and OH comes to here, which gives you that product. Now the other version is if you go and remove it from the other carbon, which I will draw you right here. And you have CH3, C double bond CH, and CH3, CH3. Now in this case again, because this carbon has more hydrogens, rich with hydrogens, he will get hydrogen and OH will go to here. So that's why automatically this alkene is also possible X, one of the possible X reactants. So they didn't state it clearly, so either one is correct. And if I'll draw the line diagrams, they will be looking like this. And the other one is like that. So this is that, and this is that. Now, what else we have left? It's telling us to find the third member of alcohol. So alcohol, we start with methanol, CH3OH, and then we got C2H5OH, and then we got C3H7OH. So we're talking about either propanol or isopropanol. We haven't been given any information what happens with oxidation. So compound X, write the full chemical reaction. So Bayer test, you guys can do it, right? So Bayer test, if I will do Bayer test on this, KMnO4, H2O, I will get, so OH here, and then another OH here on the double bond. And if I'll do it on this one, Bayer test, I will make OH here and then OH here. So we have that. The other questions, the brom 2, you can do it yourself. Bromination, calculate the mass of organic compound found in 3 if 40 grams of bromine. Now these are just the easy stuff. You can do a stoichiometry. So let's say you grabbed one of the compounds and then you added brom 2. So brom comes here, and brom comes here. So the this is 1 mole, 1 mole, and 1 mole. If it's brom 2 molar mass is 160, the 40 grams of bromine would be just 0.25 mole. So it's asking us to find what? Calculate the moles of organic compound in part 3. So how many moles of this you need to use, which is also 0.25, because 1 to 1 gives you 0.25 to 0.25. And the last one, write the balanced chemical reaction of hydration compound X, which we did. I did the hydration reaction, and everything is written in here. Also, you guys need to be prepared for overall writing a bunch of reaction in one scheme. So let's say if I start with alcohol, I'm gonna start with pentanol. Pentan just 1 ol. And I'm gonna oxidize this, and I will oxidize it one more time, the product. So this is X, and then I make Y. And then if I will do like this, I will increase the temperature more than 40 Celsius. I make a product Z, and then I make temperature less than 140 degrees Celsius acidic environment in both. I'll make the product G, and then let's say I took this, and I also have, let me tell you that I've got but 1 in. I hydrate this product. Hydrate the product. I hydrate the product, and overall I've got in here product K, and then K and Y combine and give me the product M. Okay, so let's say you started with this and you need to draw all of the structures. Now in here I know that pentanol looks like that, right? So that's pentanol. Now if I will oxidize this, it's gonna be just going to give me an aldehyde because it's a primary alcohol. Now that's X. And then if I will oxidize this one more time, that's Y. You need to know the name. So this is pentanoic acid, noic acid. This is pentanol. And then in here, if I'll make the pentanol, if I will increase the temperature more than 140 degrees Celsius, I will make alkene. So I'm gonna get alkene like that. That's the Z. So pent 1 in, because this one is alpha carbon, this is beta. You lose OH from here and H from here. And then for this one is less than 140 degrees Celsius, so this is gonna be ether. So the basically structure look like this, the G, this is Z. And then if I'll grab K and Y and combine them together, so I need to get the K first, sorry, I didn't get the K. So if I do hydration, I know that it will go according to Markovnikov rule. So this side is, so this side is richer with hydrogen. So I'm gonna add the hydrogen there. So my K is gonna look like this, right? Now, and then if I combine them, pentanoic acid and this butanol, this is butanol, the structure is gonna look like this. So I grab the OH from here and H from there. So I'm gonna draw the structure in red. So pentanoic. And that's how you get the final product M. Okay, anyways guys, that wraps up everything for you. I hope you good luck, prepare well for the exam. See you tomorrow, and please let me upload the video. I've been getting emails non-stop. Thank you very much.